Hey everyone, my name is Ovidiu, and I'm really excited to be here and to be able to share my thoughts on testing React components. So why testing? Why is this something that I want to talk about? Why is this something that's interesting? Um, well, it's because both from my experience and from the experience of working with other people, I noticed that when it comes to React coding, so just using React itself, writing React components, people are pretty pleased. The satisfaction is pretty high. But when it comes to writing tests for those components, I think sometimes we have mixed feelings. It's not always so obvious what the clear solution is, and there's definitely a lot of uncertainty. So I believe that building great software is a combination of writing code and testing that code, and I would like to help bring the latter closer to the former and make the testing experience as enjoyable as the React coding experience. So before I get into it, I want to find out something about you real quick. How many people here are using React on a daily basis, like developing with React? And how many of you are writing tests for the React code that you write? So a lot of you, which is great. Um, I think that when it comes to this topic, the audience is maybe split in three categories. The first one is people who are not testing at all. And I think this is going to be useful for you, but it's maybe not the first, it's not the best resource to get started. There's definitely other how to get started guides. But I still think this is going to be interesting because I get into some stuff that I wish I knew before I started testing, and that probably would have solved me a lot of headaches. But if you're one of those people, and it seems like most of you are, who is testing but maybe is not 100% satisfied, maybe has some issues, some questions, then I think this is mainly for you, because I fall into that category as well. And if you're one of those people who are testing and have no issues with it, it's just perfect, then first of all, I envy you, but I still think there might be something useful you can get from this talk, and if not, then it would definitely be useful for me to talk to you and learn something. So before I talk about like any advices that I have or ideas, I want to do a quick overview on testing in general and talk about why we want to test, but also what the downsides of testing are, because if we think that testing only has upsides, then it doesn't make sense why not all of us are doing it, or why sometimes we have a bad time doing it. But the pros are more obvious, and I think you've heard most of them before. This is not a technical thing, it's just how I see them. I like testing because it gives me a lot of clarity. So mainly this means that it improves my design. It makes me think about what I want to accomplish before I start getting into it, which is very useful because it's common for us programmers to think about something halfway and then start coding it. And then when we get to the halfway, we realize we didn't think about the other half. So it improves my design a lot. It also gives me confidence because I get instant feedback when I code. I think something's gonna work, but there's the tests that say this actually works as you expect it to work. And finally, I think they help a lot with regression, and this is also a type of confidence. But instead of saying the code that you just wrote works, it says that the code that you just wrote didn't break the code that you wrote the last day or even last year. So there's a lot of pros to testing, and this is just one way of seeing it. But I also want to look into what's the downsides of testing. And maybe the first thing that I can think of is just the fact that you type more. But I don't think that's the answer to it. I think that typing is not necessarily bad. And we spend most of our time thinking about our problems, not just writing code. So this is kind of silly, but another thing that I noticed, and I'm going to focus on this a lot today, is the fact that it makes refactoring much harder, and it takes a lot more time to refactor when you have a lot of unit tests. And at first, it sounds like it's natural. It sounds like this is how it should be, but it's a real cost, and I think that's why some people avoid testing altogether. And before we go even deeper, I also want to just look at what a test is, and what is anatomy, what the structure of a test is, to understand what testing a component feels like. So on a very high level, the test is split into three things. You have the setup, you have the action, and you have the expectation, something that you expect to happen. And I think something that we often do is to compare a UI component, a React component, with just a pure function, which in some cases is true. Some components really are pure functions, but most of them aren't. And I think this can be misleading. So if you analyze like what the test for a pure simple function looks like, the setup would be just having the arguments ready. The action would be just calling it, and the expectation would be just, I want the return value to be this. But when you look at UI components and all that they can do, I think this becomes a bit more complex. So the setup is a bit more nuanced. We're talking about React, so you have the props, you have the state, and also you have the context, which is not explicit. You cannot pass it to an element. It's basically set up by a global or a parent provider. And the inputs become a bit more complicated. But actually, I think that the context goes well beyond the React context. It's more of a high-level concept and something that I'll get into soon. And then if we look at the actions, we render the component, which is similar to rendering a function. But then we also simulate a bunch of user events who are synchronous, who happen later in time. So all of a sudden, the component has a life cycle, and there's a bunch of actions that happen in time that we have to account for, which is much different than just testing a function and checking the return. And yeah, the expectation is the render output, again, similar to a function, but also a bunch of side effects, which sounds bad, but most of UI development is side effects. So when you render a component, maybe it does something on mount, or maybe it does something when you trigger a user event. So all these things put together, I think that they show us that testing a UI component is much more complicated than testing a function, and I think we have to take this into account. And we have to create examples that mimic real life more than just examples that use a component or test it like a function. And now I want to get into like the main part of this talk and something that I'm really passionate about, and that is the impact that testing has on refactoring. And there's a lot of theory involved, and I'm already talking a lot, so I tried my best to see how I can turn this into a practical example and validate these issues and also be able to efficiently convey them here. So what I did is I created a sample component that's not too simple to mimic something real life, but not too complicated to be able to explain here. I'm not sure if you can see that real well, but it's a login form. It does what you'd expect from a login form. It has a username, a password, a submit button, and you can put data into it, you can submit it, and it does a fetch request. It gets a response, and it has a few states. It has a loading state and an error state or a success state if it actually worked. So I started with this component, and I wanted to write some tests on it and write different types of tests, and then keep refactoring on it and see what the experience is like. See what it's like to change something in the implementation of this, and how much work is that on the testing side. So this is gonna get a bit nerdy, but this is what we're here for, right? So I'm gonna show you some tests. I'm not gonna show you the actual test code, although that does exist. Like this whole presentation is based on the code. I'm going to show you the test names and what the files they belong to, because I think it's easier to talk about it at this level. And I'm going to talk about a concept that is difference between writing what I call tight unit tests and loose unit tests. And I think tight unit tests is something that most of us are already familiar with. It's just deciding that your unit is the smallest module possible, just a function or something, a stateless component, a Redux action, something like that. And I started with this approach because I think this is the traditional approach and this is what I used to do for a long time. And these are the tests that I came up with for this example. So this is the form, and the form is what you'd usually expect. It's a stateless form. It receives the state from above, and it responds to changes by merely sending those changes through some function props. And then it can render different states. Pretty straightforward. Then I added some reducer tests, which are always fun to write because they're so easy. You just pass in some actions and the state changes, so yeah, it feels good. The same for the action creators, I guess you'd call them. This happens when you call a function that's called an action creator. This is all Redux, by the way. It's a bit of terminology, but I won't go any deeper into this. And I think the bigger point doesn't have to do anything with Redux, but I'm sure most of you are familiar with these terms. So you test the actions. Again, it's very simple. You call a function and it returns an action. It's an object. And it gets a bit more complicated when you have async actions. You see, like the first ones, the change action is very simple, but when it comes to posting, that's an async action. So not only does the action do something external, which is to call fetch, and I expect that it calls fetch with a certain arguments. Also, it dispatches other actions in return. Like it dispatches an action that sets the status to loading, which it gets reflected in the UI, but it also dispatches an error or a success action later in time when the fetch response arrives. And finally, because if you want to have full coverage and you really think about testing seriously, I guess, sometimes you're going to end up even testing like the connected component, because if you don't test that you're going to have a leak in your test. And at this point, it gets a bit tedious, but it's still pretty simple and satisfying. So at the end of this experiment, testing with this tight unit test approach, we have 4 files, we have like 18 tests, and looks pretty good. Now I want to try something else. I want to try a test approach that doesn't even know that I use Redux, doesn't know that there's a connected component and an inner component, and just looks at it from a user standpoint. So let's see what that looks like. It looks pretty similar to the form test from the previous example, but this one tests everything end to end, I guess. So it checks that the inputs are rendered, it checks that the updates occur, but when the updates occur, you don't check that some prop is called, you actually check that the input value is different, so the render output changes. It does know that you're doing a fetch request, so it does know something about how you implement it, but I think that's much better than knowing about Redux internals. And then, yeah, it just checks that the specific states are rendered when the response comes. And the first thing we see is that there's a lot more tests on the left. But as I said, I don't think the issue with certain types of testing is too much typing. There's definitely some benefit to testing how you do on the left side, because it's more explicit. I don't know, I guess it's more easy to reason about. But I think what's going to happen next with this test as I start to refactor is much more interesting. So the first refactor, I do something radical. I replace Redux altogether with set state. This is a bit wild. I'm not saying you should do this. I'm not saying Redux is bad. I think it's pretty cool. I like both. But I just wanted something that's really hardcore. that really changes the implementation a lot, but doesn't change the outcome and the user behavior at all. So this is what the refactor looks like. So on the left side is what I guess the component hierarchy looked like, but it's not just components, it's more of a module thing. So you have the provider on top, and it has the login form, which is a connected component, and inside it's the login form, which is a stateless component. And then you also have the actions and reducer that make everything work together. This is the previous architecture. And then after the refactor, you get something like this. You get a stateful form which uses that state, and then the same login form as before. This one didn't change; it's a stateless component. Pretty cool. Let's see what the tests look like. Well, on the tight unit side, the login form is the same, and this is nice. We didn't have to change anything; it still works, but we didn't change the component. That's why. But we had to add a lot of tests for the new component, the one that manages the state, because that's new, so of course we have to test it now. And not only that, we get to remove a lot of the previous tests, which don't mean anything to us anymore. And I think this is a pretty frustrating part. But it happens a lot. But when you look at the right side, nothing changes, which is pretty cool. So I like this kind of response from my experiment, but I can understand that this might feel like an artificial example. You don't change your Redux store to set state every day. So I went along and did another one. And this is something that I think occurs more often. It's extracting an abstraction from something that you already have, so you're able to use it in more places. So you go from the stateless login form and just a login form to the stateless login form, a login form that's merely just a config for a form that uses a generic form that is able to handle like a dynamic range of inputs, and you want to be able to use it to build other types of forms. And again, we do the experiment, we look at what the tests look like. This time the state test didn't change because now the outermost component didn't change, which is also cool, but we had to add completely new tests for the form abstraction. We had to add completely new tests for the login form, because whereas before it was a standalone component that rendered inputs, now it's just a config. It's a wrapper component for a more abstract component. And we had to remove a lot of tests. And on the right side, guess what? Again, we didn't have to change anything. So we went from a Redux connected component to a set state component, and then to a component that uses some generic form that we can reuse in other places, and didn't change the tests at all. And you know, this is just a visualization, but you can look at the tests afterwards. I will share the code base. These slides are actually generated from actual tests. So quick takeaways. I think writing this type of tight unit testing slows down refactoring. I felt it, I saw it in other people's experience, and also I think that a lot of the tech abstractions, like a generic form, are very transitory. It's not bad to test them. Sometimes you want to test them if they're really reused in a lot of places, but most of them, they changed a lot. You can change them from, I guess, sprint to sprint, and because sometimes something really small changes in the user behavior or in the product itself, but that ends up requiring a lot of refactoring underneath, because for some reason maybe you're using something for the second time and you want to abstract it, and then maybe you remove the second instance and then you want to de-abstract it, I guess. So I found that a lot of abstractions, a lot of components, low-level components, change too often for me to test them, whereas feature-oriented units, like something like a login form or something that makes sense from a user standpoint, changes less often. Now this does not apply to libraries or some apps, but most apps, I think this is more true than false. I think features are more stable and they progress more naturally than abstractions, which always mix and morph, and testing them in great detail just makes that process difficult. But there's also a downside to testing like this. Of course, it's not all perfect. You end up testing components that render a bunch of child components. and so on. And the test setup can be much more complicated. And I think that we have to acknowledge that. And I want to address something that we've all seen a lot of times, this idea that a component is just a function of props and state. And I think this is overly simplified. It's technically true, but on a higher level, I think that there's a context that plays a big role in the component's inputs. And if we don't see that, then we're going to have surprises when we want to test a component. So again, context is not just React context. It's a more high-level concept. It can include shared app state from something like Redux. It can include like a theme or a locale config or even server data. And this sounds weird, but I think that server data is actually an input for a component. For most components, server data is a prop, but for the component that fetches the data, it's not a prop. It happens, it's gathered inside the component's lifecycle. And if you want to test that component, which I think you should, you have to see it as an input, and you have to be able to provide it in a way in your test environment. And this can be like local storage as well, and even window size. I mean, there's so many things that we use in our tests, which sound like bad practices, but most of us use it at some points, and we like to extract them in a lot of abstractions and test that on their own. But as I said with my previous examples, I think that's not necessarily productive. So once we understand this idea that the input for a component is actually a complex array of things, we can start making this easier. So this is a concept that I call declarative mocks, which is, it starts with the simplest example, which would be weird maybe for most of you to see as a mock, but I see it as mocking props. It's just a component that receives a simple input of props, but you can also pass it state. This is a helper that I sometimes use if you want to put that component in a certain state. But you can use this concept and use the React power of declarative programming to mock anything. This is something I'm sure you've seen or used before, but you don't have to be confined to just Redux context. You can take anything and put it in this form. You can mock a URL like this, and by the time your component unmounts, everything is cleaned up. You don't have to do a lot of setting up and cleaning up in every test. I do this for things like local storage, and once even did it for mocking the window size because it was relevant in that project. So to recap this idea, I think that loose unit testing, which I'm a big fan of, increases the test setup, and I think that's a big no-no for many people because it makes you more aware of all sorts of internal stuff when it comes to like the inputs of your components. But I think if you get into this mindset of declarative mocks and getting to understand what the inputs are, it can simplify it, and I still think you can get a lot of value in testing like this. So there's a bunch of questions that usually come up. I don't have a lot of time, but I'll just go really quickly through them. One of them is to mock or not to mock. I'm not against mocking. It's actually a bit of a paradox because I say you shouldn't mock children, you shouldn't mock like actions and other modules, but now I just talked about mocking a lot of things. But I think the main difference is mocking modules, which I think change a lot when you refactor, and mocking data, which I'm a big fan of because understanding your data is a very healthy thing in UI development. So I'm a much bigger fan of mocking data in this scenario. But I ultimately think you should mock whenever it's more useful to test that way. You shouldn't mock when it's more useful not to. Shallow rendering is not really useful for me anymore because I can only test one layer of components, and that's usually like a higher order component or something. So I just don't use it anymore. One disadvantage of this type of testing is that you get more noise, and this is something maybe we can talk about in private after this. It's definitely a disadvantage, but I think it's not as bad as it sounds. Pure unit testing promises the fact that you break something and you only get one test that fails, and that's a utopia first of all, but I think that having more tests fail when something breaks is not that bad. What level do you test at? Means that if you don't test just like the lower level components and you can test at a higher level, where do you stop? And this is more of an open-ended question, question, I find that I test at the level of hierarchy where um, where I want to cover more code paths. So if I want to test if I want to have full coverage of the abstract form that I just showed you, I'm going to test the abstract form. If I want to have full coverage of the login form, I test the login form. And I'm going to test the abstract form implicitly, but not on all paths. This isn't end-to-end testing, even though it sounds like it. End-to-end testing is usually URL-based. I think that's the main distinction. I think that in a component-driven architecture, you want to have a component-driven testing architecture as well. So I want to be able to test one component and not go to a URL and click, click, click. And it's also, it's much faster and you get coverage as well because you're testing the source code. Finally, is this integration testing? I don't know. This is just one of those things. I don't care that much, and it seems like other people aren't as well. This is a quote that I like from Kent Beck, which says that it wasn't really helpful for him either. And another quote that really struck home for me is this one, which says that although I start with the notion of a unit being a class, this has nothing to do with UI testing, by the way. I often take a bunch of classes and treat them as a unit. Sometimes I'll even take a subset of a class, which I wouldn't do, but I like the freedom. And it doesn't really matter how you define a unit. What matters is to make sense for the team and the project that you're working on. And this is something that's been said from someone that has thought about testing a lot more than I have. So with that, I'm going to end. My name is Ovidiu. I'm an independent developer. I've been working in a lot of environments, but lately I'm just building open source code on my own and really involved in some projects that I don't have time to talk about now. But if you want to find out about them, just follow me on Twitter. That's where I post all my updates and everything I do. And actually, before I go, because I think I'm over time already, I just want to post the slides real quick. So I don't know if it worked. It's going to work eventually. You can find the slides here, and you can look at the examples and everything. And yeah, thank you.